Good day viewers, and welcome back to channel. Welcome back to class. Today we are going to have a look at some calculations carefully selected that have to do with calculating relative atomic mass. Let's just start. Remember, mass number of an element is the number of proton per number of neutron. So let's do the calculation and see how it goes. The first calculation goes thus. Two isotopes of chlorine exist with mass number 35 and 37. If the isotope exists in the ratio of 3 to 1, what is the relative atomic mass of chlorine? Remember, when you are doing it, you see the first one, 35, 37. First of all, you see ratio, sum of the ratio equals 3 plus 1, which is 4. Then the first one, the way they appear, the first one is 35, while the second one is 37. You write it like that. Then when you are calculating, say calculate what is the relative atomic mass. You now say relative atomic mass is first one you have is sum of both percentages, 33 over 4 over the total times 35. That's relative atomic mass, plus 1 over 4 times 37, the way it appear, over 1 over 1. So let's sum it and see. These ones are not that tedious, it's just a direct approach. 3 times 35 give you, divide by 4, you have 26.25. 26.25 plus 1 times 37 is 37. So just have 37 divided by 4, give you 9.25. 9.25. If you sum the two together, you have 9.25 plus 26.25, give you 35.5. 35.5, which is the accurate value for chlorine, an isotope of chlorine. So that's how you calculate the first one. Remember, you just find the ratio by summing it together. You arrange it like this. So let's go to the second one, which I believe is a bit more tedious. It's a bit more tasking, but you can overcome it. Just understand the basic principle. Chlorine contains only two isotopes of mass number 35 and 37. Relative atomic mass of a given sample of chlorine is 35.5. Calculate the percentage of chlorine 35 in the sample. How do we do it? You say percentage. Okay, let's say percentage of chlorine 35 equals A. Then therefore means, therefore, percentage of chlorine 37, because they said they have two chlorine, 35 and 37, will be 100 minus A. So that's how it's going to be. Then they said chlorine contains only two isotopes of mass number this and this. The relative atomic mass of a given sample of chlorine is 35.5. Calculate the percentage of this in the sample. You now say for this first one, you have relative atomic mass equals percentage. This, remember this percentage A over 100 times 35 for this, plus 100 minus A over 100 times 37. Remember they've already given us this as 35.5, which gives you 35A over 100 plus 37 100 minus A all over 100. It now gives 35A over 100 plus 3700 minus 37A, everything over 100. Remember, both of them have 100, 100. So you make it the same. 35A plus 3700 minus 37A all over 100 because they have a common denominator. Then you subtract this from this, now becomes 3700 minus 2a. This one, this will give you 2a over 100. Let's see how it goes. And become this one, they are the same. 35.5 equals 3700 minus 2a over 100. Cross multiply. 35.5 times 100. Let's see what we have. 35.5 times 100 give you 35.5 times 100 give you 35500. 3550. This is what it will give you. 1 2 1 2. Yes, this is what it will give you. Equals 3700 minus 2a. So let's go to the top. You can just keep this one first. Let's start from here because of the nature of the board. Or let's go to this side. Okay. So now subtract, carry it to this side. 3550 minus 3700 minus 2a. So it now becomes minus 3550 minus 3700 give you minus 150. Minus 150 equals minus 2a. Charge, cancel charge. 2a equals 150. A equals 150 over 2. A equals 75. That's what we give you, meaning A equals 75%. A is 75%. So look at the question again. Calculate the percentage of chlorine in the sample. So the percentage of chlorine of chlorine 35 in the sample is 75%. But in case you are told to calculate the percentage of chlorine 37, all you need to do is to remove that 35 from 100. It now becomes Cl37 equals 100 minus 75, which is 25%. But this is not what they ask from you. It's just this. So my friends and viewers, this is how you calculate relative atomic mass, and this I believe is one of the ones that is a bit tasking. The rest are easy to solve. Note it very well. Follow the processes. See the way I started it by equating this one to A, because you don't know, there are so many unknown. Equate this one to A. Once you equate this one to A, since it's a percentage, you have to subtract it from 100 to have the other one. Thank you very much. Please kindly subscribe. God bless you. Shalom.